Let's look at some rational or fraction exponents. We've got a lot of experience with integer exponents. For example, 4 to the first power is 4. Any number to the first power is itself. And when we multiply that number, so 4 times 4 is 4 squared, that gives us 16. And then multiply by another 4, well, that's 4 to the third power, that's 64. So as each exponent goes up by 1, we multiply by 4. We've also discovered that if we go backwards from an exponent of 3 to an exponent of 2, we divide by 4, or multiply by 1/4. So 4 to the third power is 64. Divide that by 4, or multiply by 1/4 to get 4 to the second power, that's 16. Divide that by 4, or multiply by 1/4, and we drop the exponent by 1 to get to 4. And that's how we discovered that we'd have a 0 power. We keep following the same pattern of dividing by 4 or multiplying by 1/4 and subtracting 1 from our exponents. That also led us to negative exponents. We just keep subtracting by 1 and multiplying by 1/4 or dividing by 4. If we go up, we multiply by 4. If we go down, we divide by 4. Well, these are all integers. Could we have fraction or decimal exponents? For example, the number 1/2 is between 0 and 1. Is there a 4 to the 1/2 power? Yes, there is, and it is 2. Could we have an exponent of 3/2? That's between 1 and 2, because remember, 3/2 is the same thing as 1.5 or 1.5. Yes, we can have a fraction exponent there between 1 and 2 of 3/2. 4 to the 3/2 power is 8. So we can have fraction or decimal exponents. Let's take a closer look at how to evaluate them. The 1/2 power is the same thing as a second or square root. So anytime you see a number to the 1/2 power, we will take its square root. That means any square root could be written with an exponent of 1/2. So here's 100 to the 1/2 power. Well, that means it's the square root of 100, which is 10. Our goal is we want you to be able to skip that middle step and just realize that 100 to the 1/2 power, well, that's the square root of 100, it's 10, without having to write the square root. So we want you to get used to the fact that anything to the 1/2 power is the square root. So you try this one and evaluate what 9 to the 1/2 power is. It's 3. Oh, what about a negative exponent? 100 to the negative 1/2 power. Well, remember, a negative exponent pushes our base across the fraction bar. That's like 100 to the negative 1/2 power over 1. So we'll push it across the fraction bar. Now the exponent is positive. Oh, we know that 100 to the 1/2 power is 10, so our answer is 1 over 10, or 1/10. You try this one. Pause the video if necessary. And hopefully you got 1/3. The 1/3 power is the same thing as a third or cube root. We could keep going on with this. The 1/4 power is the same thing as a fourth root. The 1/5 power is the same thing as a fifth root. Let's take a look at an example of a 1/3 power. 125 to the 1/3 power. Well, that's the same thing as the cube root of 125, and we know that is 5. Again, our goal is we want you to be able to skip that middle step and just go right from 125 to the 1/3 power. Well, that's the cube root of 125, and just write down 5. You try this one, 8 to the 1/3 power. Pause the video if necessary. The answer is 2. That's what 8 to the 1/3 power simplifies to become 2, the cube root of 8. Ooh, a decimal. What should we do with decimal exponents? 121 to the 0.5 power. Well, remember, 0.5 is the same thing as 1/2. So we can write this 0.5 as 1/2. Now we can see it's 121 to the 1/2 power. That's the square root of 121, which is 11. You try this one, 49 to the 0.5 power. Pause the video if necessary. (49 to the 0.5 power simplifies to 7. Well, what if the numerator isn't 1? Here's 16 to the 3/2 power. Well, let's follow these steps. Put the base and a fraction exponent that does have a numerator of 1 in parentheses. So I'll put 16 to the 1/2 power in parentheses. I'm going to use the denominator that was there, and then instead of writing 3, I'm going to write a 1. However, I've still got to make this equivalent, so I'll put the original numerator as an exponent outside the parentheses. That's where the 3 goes. And this is okay because if we go backwards, we know our power to a power rule. 16 to the 1/2 power taken to the third power, we multiply the exponents. 1/2 times 3 is 3/2, which is where we started. So this is okay. And a lot easier to simplify, because we will now simplify inside the parentheses. Well, 16 to the 1/2 power, that's the square root of 16, which is 4. And then we'll use the outside exponent. 4 to the third power, 4 times 4 times 4 is 64. You try this one, 8 to the 2/3 power. Pause the video if necessary. You should get 4. We put 8 to the 1/3 power in parentheses and the 2 outside. 8 to the 1/3 power is 2, and 2 squared is 4. What about this craziness? What's this? 81 to the -5 power and all that to the 1/10 power, that looks insane. It's okay. We can use that power to a power rule to our advantage in this problem, because we can multiply the exponents. We'll take this -5 times the 1/10. And -5 times 1/10 is -5/10. That reduces. So it's really 81 to the -1/2 power. And we remember, a negative exponent pushes us across the fraction bar. So that's really 1 over 81 to the +1/2 power. And 81 to the 1/2 power, that's the square root of 81, that's 9, and it stays downstairs in the denominator, so that all simplifies to 1/9.